Hello, Hendrik speaking.
Hello.
Hi.
Good morning.
Good morning.
Good afternoon, but yes.
Good morning.
Hey. All right, let's suggest we wait 1 or 2 more minutes. We had another couple of guys saying they would join. Maybe I can, in the meantime, share again the link to this document we're working on and that I polished a tiny little bit since last time, but really just a tiny little bit. And again, this architecture picture. Hey, Amanda.
It's nice to see faces.
Yeah, indeed. So you have heard that PyPI was blocking new account creations and packages over the weekend because they were not able to handle the deployment of malicious components.
Yeah, I did read about that.
That happened over the weekend. I think a couple of guys were off on vacation, and then, yeah, there were just too many malicious packages being published in the week before, so they decided to temporarily forbid new accounts being created and packages being, I think actually it only affected entirely new packages, not new package versions of existing packages render, right?
Correct. It was people that were publishing that hadn't published before.
Yeah. All right, and the third link is to this Risk Explorer, which we will use again when we go over the different threads or different, let's say, assets and systems of the architecture. So maybe let me share my screen. And we just start. I don't think there will be any other. Let's see whether somebody else joins. So maybe I can summarize a bit what we have done last week, which I found was a nice and productive meeting. So we basically went, let me share the screen before, and so I can show a little bit with the document. Share screen, this one here. Yes, now you should, do you see me?
Yep, you're sharing both your screens, just FYI.
Okay, no, I don't want to share both. Thanks. Just this one.
I'm still showing both.
No, it's not both. These are just, it's a split screen.
Oh, fair.
Okay. All right, so last time we were basically discussing different security threats materializing on the developer machine on the very left-hand side of this architecture diagram, and we came up with a good number of threats that I have documented here. I just changed a little bit the a few phrasings here and there, but not very much. And so what we have come up with is basically, it was all around, whether there is a defined tool set to be used by developers of a software organization, whether there is an approval process that is maybe incomplete, whether it covers all the versions, whether it also describes the distribution channels that can be used by developers to obtain their dependencies. So this is basically all of the above that relates to kind of documentation, governance, approval processes that control how and what developers install. This one is one that we had even before last week's session, which is about misconfigured package managers that go and get stuff directly from the internet rather than going through private registries. And then the last two ones are basically different attack vectors that we picked from the right-hand side from this attack tree, the topmost node, which is basically malicious packages developed from scratch that get malicious code at later points in time, at later versions. And the second one, AV200, refers to that one here in the middle, which is summarizing all the different name confusion attacks, such as typo squatting and so forth. So these are all threats on the developer machine. And then my thought was maybe go and discuss whether there's anything else on the developer machine missing. Certainly, the question is, can we come up with something now? Or whether it makes more sense and whether it's more productive to go and identify some threats for all the other elements on this architecture diagram. And for those that haven't been in any of the previous sessions, on top of this architecture diagram here, we started basically defining the scope, the assets, as well as a couple of a good number of data flows that are related to basically open source packages and proprietary code flowing through the architecture and system outlined above. Right. Any comment or input so far?
Yeah, just additional possibilities. So I think laptop usually nowadays, at least for the employer I work for, nowadays have backup in place to back it up to remote location. So that backup itself is a risk, right? So that whatever is on the laptop is on that backup. I guess.
So what you mean is, because we look at threats related to the consumption of basically malicious open source components, right? And so do I get it right that if a developer is backing something up, that backup is tampered with and then he restores it on his or her developer machine, this would be a vector?
Yeah, I guess once it's backup, there are multiple ways to use that backup. One way is, as you just said, maybe the backup can be something can be added, malicious code or virus can be added to the backup, and when developer restore to the developer machine, that the problem comes back to the developer machine. It's also possible that the password file or key files, whatever is on the secrets that's stored on the developer machine, could be accessible on the backup. So then that can be used to, I guess that's still considered part of the supply chain attack.
Yeah, this is for me the question, because I mean, the basically the assumption or the scope we said is for the time being to exclude insider attacks, which I guess would be the ones related to what you just described. Because, I mean, the backups, those potentially malicious or those malicious open source components come in through those reddish data flows. And so if a developer machine but the developer backup would not, be stored outside of that organization, right? And would be unrelated to those data flows. So even though in general I agree, but that this could be a problem as long as we exclude insider threats, I'm not sure how this can be a vector for consuming malicious open source.
Okay.
You know what I mean?
I think that I think it walks a very debatable line, because I have argued many points of view when it comes to backup, and there are many points of view, because there's also the point of view of the most secure backup that you can have is no backups. I mean, I don't necessarily agree with it, but I mean, I guess. So I think that I agree with Henrik. I think that we should focus more on supply chain specifically, because I think that that's an entirely separate topic about backups and integrity of backups and where you keep your backups and the setup of backups. And there's a bunch of different programs that you could use, even though on Linux, we all try to use kind of the same stuff. But I think that it distracts the topic, if you want my personal opinion.
Mm-hmm. Or Victor, do you see any way to twist this so that it is relating more to this malicious open source consumption?
No, I agree. It's probably not directly related to the red line that you have so far. Yeah.
Mm-hmm. Any other threat we could have missed here?
Now let me say this on the topic of backups. I guess theoretically, some package managers do allow you to save something of like a set. Because you get where I'm going with that, Henrik?
Yeah, I wonder whether this is related. Yeah, no, please go ahead.
Because all builds are supposed to be replicatable on everything except Gentoo, basically, right? Like every build is reproducible every single time. You should be installing the same thing. So theoretically, I mean, there could be a way of like managing package integrity, I guess is what we would be talking about, and like backing up like a certain setup. I mean, but it would be more from like how do I like save this type of situation. Like I have a setup that I have audited, I feel secure about. How would I be able to reproduce this setup in another machine? You see my point?
Okay. Yeah. So but this is somehow related to this misconfigured package managers, right? So you're supposed to set up your machine in a certain way, and the question is, how reproducible is it to set it up according to your requirements and the process you have come up with? Is this?
I guess it depends. It really it really depends. But I mean, yeah, it was just a thought that I had as far as like, what would you do if you wanted to like maintain a certain package set and you wanted to maintain the integrity of said package set on the developer machine, if that makes sense.
Yeah, this rings a bell, and I think of an attack that I'm not sure whether this was just a proof of concept or so, but here basically malicious packages were able to modify cached packages that were used in other development projects. So basically, as soon as you start caching your downloaded stuff, such as your local M2 Maven repository, any malicious code could alter those. And maybe that is that is more related.
That's
this
true.
this could happen on a build system, and this can happen also on a developer machine.
Fair argument.
Okay,
it was just a thought. It was just a thought that I had.
Okay, I just wonder where to put this then. And also I wonder, I mean, the fact that such a local cache could be tampered with by another malicious open source component, does this need to be documented as a separate thread or not? Because
that would be a separate threat, because in order for you to modify the caches of the package manager, if I remember correctly, you would have to physically like go in, like, for example, I don't remember where Gentoo keeps it, but there's a folder, the dist files is what we call it, DIST files. And basically all the installer files and whatnot that get downloaded by Portage get put in that folder. So if you were to go into somebody's machine and tamper with that file so that the next time somebody were to install or try to execute the same install for whatever reason, and now it would not download anything because it would say, oh, well, I have this other file, then you would need access to the machine though.
Yeah, and either that, or it would be done through another malicious package, but then, I mean, this would be a secondary impact, not because the thread would still be running the
theoretically, that would be caught, right, by the ACLs or because it would be very difficult. Like, you would need to have administrator privileges to modify those files, right? Most of the time, at least, one would hope.
Okay, so let me just write up a couple of notes. Through physical access, which comes back to insider threads or other.
And that could also go for like a build server or whatever. So therefore you just modify and screw everyone up.
Yeah, so I think here, this one, tampering with local caches through physical access or other malware running on that machine with those privileges. Let's say this is something that I can replicate right away to the build system, I think. Right. I mean, the idea here was, when I was playing with this thought, is, so if a developer declares a dependency on something, then maybe he is less reluctant and less careful when it comes to consuming a test dependency, right? And so that could be a way to sneak in a malicious component more easily into a developer workflow, and that test dependency then manipulating cached local copies that are used on that machine or on that build system, or maybe changing the source code of the application itself right away, maybe compiled Java classes or the source code files.
Correct.
Kind of that is the train of thought that I had when it comes to test
Just
dependencies, for example. Yeah.
Let's confirm all the regular, you can say it's kind of a classic attacks, such as phishing of physical theft, software, just someone take the laptop, unsecured, unencrypted. Those are not in scope, right? Those are just a classic threats. Correct. Rather than supply chain threat. Okay.
Yeah, I think we excluded also all kind of physical security related topics, honestly. Kind of, laptops being stolen, not encrypted, and then tampered with or so. Okay, and I copy this here. Okay, and I note down the same thing that unencrypted disks. I would say also are out of scope as well. It's really all what relates to the consumption of malicious open source and the damage it could do, I would say. I'll bring this up here.
I would also like to point this out, Henrik, because it's not really there. Not really a threat, but I mean, it's a very dangerous ideology because we've always said in open source, trust but verify. And I think if you don't do that, that in itself is a threat.
Yeah, but okay, but does this relate more to the general mindset that you would expect from a developer?
That might be true. I mean, that you have a point there. But I mean, I'm just saying in general, because if you're gonna, I think the point of the supply chain, right, is the fact that like a lot of people live with the ideology that things like package ecosystems are going to have their best interests at heart at all times. And while that is the intention, certain things happen and things can happen where inadvertently certain things can break or certain bad actors can be introduced. But the thing about it is that like that's not really the package ecosystem's fault. It's really like to some degree it might be, but it is a community and it is something, I mean, it is open source. So I think that's where like if you're going to be a safe user, no matter what you're doing, you have to know what you're installing. So I think that's where like the trust but verify ideology comes into play, because at the end of the day, it doesn't really matter how good of a supply system you design. If you're never actually going to care to like understand what you're installing and how it got to your computer, then it's all kind of really pointless, isn't it?
Yeah, I think we started having this discussion last time as well, and I reflected this in this this bullet point here that I just highlight. I wonder whether, whether to phrase this as a threat or maybe educate developers and teach them this principle of trust but verify.
Maybe it should fit more in the initial assumptions and scopes rather than in a specific threat. I'm just looking at the sections of the, because it sounds like a very general kind of mindset, right? As you see, it's not a real vector.
Yeah, I think this is the attitude that we want to teach every developer, right?
I just think that maybe, yeah, I agree with what you're saying. I think we could reword it there. We could include everything, but we could do that. We could worry about rewording at the end. We don't have to like get caught up on these types of things now, in my opinion. And just to point out, Henrik, the reason that I really say this is because this is kind of a ongoing issue point between packagers and users that we currently have at all times. Because as I said, a lot of people do think that packagers have the responsibility to keep you safe. And it's kind of like we do, but we don't. You know what I mean?
Yeah. No, I mean, It's all perfectly spelled out in the open source licenses, but I guess in the day-to-day consumption of packages, you know, this gets forgotten.
Right. And I'm not gonna lie to you that sometimes it's a lot of in the attitude of the packaging teams as well, because a lot of packaging teams will have this attitude of like, and this is why I say this. They'll say it like trust but verify, but they'll say it but like in a much meaner way and kind of make it like, but it's your fault and how could you not do this? So you get what I'm saying? Like,
yeah,
like
I agree. Yeah, I come.
so that's why I think that it's one of those things where they do have a point. Just like when somebody just crashed their computer because they installed the wrong package, this might not be the right thing to say.
Yeah, but yeah, it's just not, I don't know, this whole verification, as much sense as it makes, it is just so unrealistic at some point. I had a look earlier today at the transformers library or package that comes from Hugging Face, and it has like 2000 dependencies. Yeah, good luck verifying this. I mean, but yeah, I mean that we can have those. This is not leading anywhere, I guess. It's just we don't have the tools to let developers verify this properly.
Yeah, it's
and so
very strange.
So kind of we trust that the Hugging Face guys did the job, and they trust that their upstream projects did the job properly, and yeah.
Yeah, and let me also say this, Henrik. I think also in terms of this getting mass adoption and whatnot, I think one of the big pieces of feedback I get at LF sometimes is that OpenSSF likes to champion a lot of things, but they don't realize that security has been an issue since Linux has been open source in 1991. So there are several generations of different people that have tried to address the security issue. And I'm not going to say that there's a single solution that is perfect for every situation, but some people think that OpenSSF isn't fair and that we don't consider those previous generations of things that were implemented as security measures. And I will agree with you that verification, especially in sometimes the way it's implemented, is really, really silly. Like, I won't name specifics, but I know of a package manager that just uses a SHA-256 on a package, and that's what they call security. It's just shawing things left and right. And at the end of the day, if the downloaded package SHA matches the one that we're delivering, then it passed security. And you see, that's what I'm saying. Like it's difficult because there are different generations, and I'm sure that may have worked at the time when that was implemented. I'm not saying that we have better things now, if that makes sense. So yeah.
No, there was just on that point, there was an article just a few days back, or maybe that is when I came across it, about package signatures on PyPI and how ineffective they are. In fact, that kind of a guy basically looked up, tried to find the public keys of the GPG signatures that were created on PyPI packages, and he was only able to get it for a certain number of packages. And then he was also looking into the crypto algorithms being used, many of them being weak, and he basically concluded this is not useful at all, and that probably nobody is verifying any of those signatures anyhow. I can share this maybe at a later point in time. It was a good read into this whole topic.
Yeah, that'd be good.
I'm taking a note here somewhere else. All right. Okay, so I kept that trust but verify as a maybe we can look at this again when we come to the controls.
Yeah, absolutely.
Okay. Then what are other problems on developer machines?
Well, the backup is not considered, but how about the developer machine itself, the firmware, because that's part of a different supply chain, not from the application. Is that considered in scope?
I think we had this discussion as well, right? Do we include third-party firmware as in this flow?
I think we talk about the overall, we don't consider firmware to be in scope because that's a different level of security. However, this is about the developer machine itself, the firmware, which does affect how the developer machine behave in the supply chain, right? But is that in scope?
What do the others think?
I have to think about that one because that one's not bad. It's a good one. I don't know.
Do we have an example?
Yeah.
Do we have a good example for malicious third-party firmware that? Yeah.
For example, there's another organization, independent. I forgot it's independent in its foundation. It's called Open Computing Foundation. So one of the threats they have identified is firmware virus, out of virus or security risk that after, even if if your laptop authenticated using SPF Spire, for example, it's possible for the firmware to trigger a reboot. Right after reboot, it can be remotely controlled. So by the actor, I guess, hacker. So I can bring up post that link.
Oh, so again, so this was a third-party firmware that triggered a reboot and that resulted in basically remote access by attackers.
What I read. I'll post the actual link to that thread.
Does using like a cloud development environment, does that constitute part of this threat? And so maybe you don't have control over the physical nature of the development machine itself?
Yeah, that's actually a very good point, because the development machine could be a virtual machine. It has to be a physical machine. It could be a virtual machine in the cloud.
Yeah, that is a very nice one. Yeah, indeed. I think even though we were speaking here of in-house development, I also do not want to always just exclude things. And since I really like that one, okay, so let me just malicious third-party firmware. Basically installed on developer machine or cloud machine. Yeah.
Now let me say this, that all firmware that's in the Linux kernel gets meticulously audited. So I would say also to keep, if we're talking about Linux specifically, most firmware should relatively be safe, but it kind of goes under that install but verify, I would say, because you got to figure out do I have the right firmware, right versions.
Okay, so here we don't speak more of, now we speak of third-party hardware drivers, right?
Drivers and firmware are a little different.
Yeah, but the Linux kernel, correct me if I'm wrong, it would contain hardware drivers, but there is no
certain ones that have been merged into the kernel, yes. But things like there's still a lot of hardware drivers that are distributed third party, like NVIDIA, for example.
Okay, yeah, but those are loaded separately, right?
Correct. Those are DKMS, dynamic kernel modules, which is really the ones that you need to be careful of, because those are the kernel modules that can get loaded on the fly could be a problem. But this is where the kernel has like signing and stuff like that you can implement depending if you're building your own kernel or not.
Okay, so
it starts to go down a rabbit hole. But I would say that, like, yeah, and as we said before, Henrik, I think later on when we do like a final go through, we could figure out the best way to say it all.
okay, so for the time being, I wrote this down. Third-party firmware hardware drivers integrated or not into the Linux kernel on the developer machine or in the cloud, or on some development environment in the cloud.
I just added the Open Compute Foundation's Common Security Threat version 1. The first one in the table, if you go see it, is called execution of unauthorized firmware. Scroll down to the table, it will the first one is firmware.
My main thing, Victor, is how practical of an advice is this? Because the thing is for the vast majority of users, you don't really have a whole lot of option on what firmware you have installed, like the distro comes with. So it depends, I think, on the distro, and it depends on how you have things set up.
Yeah, so now the question is, so just like a lot of time when user want to go to public cloud, right? They assume for example, zero trust, all the public cloud providers are selling zero trust to the users.
Right.
But basically they take the responsibility away from the end user. But underneath the cloud itself still have the same concerns, right? So similar to here, firmware, yeah, in most cases, user developer shouldn't need to worry about the firmware. Now, is it in scope to consider it? Whose responsibility it is to consider it then?
That's a fair point. But here's what I'm saying is that, like, if we're talking about, for example, a version of firmware that has a specific problem, like, how would a user go about controlling that? Because in most distros that I know, you either install the firmware per vendor or you just install this one huge package that is just firmware.
I think it's really depend on should it be considered and mitigated as part of this supply chain security
what
process.
I would say, let me say this, Victor. I think they're referring to, like, if you're using like Yocto project to basically create like an embedded operating system, then I think that would be when you would do this, because you would have control over everything in like Yocto project, which is similar to Gentoo. But it would only be in those scenarios that you would actually have control over this.
Okay.
Make sense?
Yeah. So I guess should it even be mentioned, even if it's not part of the supply chain proper threat model?
It is, but here's the question for Henrik. Do we want to cover things like Yocto project and Gentoo?
So first of all, I think we should So one thing that I understood from you, Randall, is that the user again doesn't have any way, or very often doesn't have a way to verify what he's using, and doesn't have an alternative either, right?
I mean, he does, but like, how useful is that legitimately? And would you be one out of like 2 people that do it? So, I mean, unless of course you're using again Gentoo or a Yocto project, because for example, in Gentoo, you can select the firmware that you want to have or you want to carry on your system. And Yocto project, you can do that as well, because basically you're doing essentially Linux from scratch and building an immutable image with everything for your embedded device that should be somewhat tamper proof. So, you know, so in those scenarios, absolutely. But like, so I guess the question, Henrik, that I'm proposing is this a developer, like, because we're talking about developer machines. So if we're going to talk about developer machines, I would almost argue that wouldn't be in scope. If we're talking about embedded programming and embedded devices, then that would be in scope.
Yeah, originally when we came up with this picture, we had more application developers in mind, right? That use whatever NPM, PyPI, Maven, Rust, and whatever else ecosystem.
Most of those people, I would say, like the firmware. Maybe I would say that might be a good addition in later editions if we decide to cover like doing it from scratch because you're going to do embedded, or you're a sadomasochist and you want to do Gentoo.
This is possible to.
What I find interesting is that. Go ahead, please. No.
Yeah, what I mean is I think it's possible to take this, just treat it like inside a thread, because the mitigation for this firmware risk basically means the corporate policy, the network policy, will not allow, like if you build your own laptop, right, using any firmware, those hardware will not be allowed into the corporate network. So as long as corporate network policy this require really strictly secured laptop devices, then this will not be an issue.
It goes a little bit in the same direction than the thought that I had, that interestingly, in such bigger development organization, I suppose these are completely different teams and responsibilities, right? So you have one group of people that tell developers how to securely develop whatever software application, and then you have an entirely different team that is, providing the machines and providing, sorting out operating system updates and all this. And so I find it interesting from that perspective.
Let me just say this real quick, Henrik, that I have had that point of view for many years. And in my almost 10 years of being a packager, I have yet to find a company that actually has a like team that oversees their packages, or that's like, hey, let's look at all of the patches that we're using and make sure that there's no junk in them or anything. I haven't met anyone yet. So I would say in theory, that's a great thought, but I would just keep in mind that in practice, I don't know if that actually happens, or I don't know if in the community that actually happens.
No, yeah, I didn't want to say that there are teams in such organizations that vet each and every version. I completely agree this is happening not very often, not to say very seldomly. What I meant is that those central security teams care more for the security in the application development lifecycle, right? They organize and prescribe the static application scanners
Correct.
to be used, or maybe some dynamic scanners to be used, and they teach them the secure development practices and all this on the level of the application. And this
Correct.
group is completely different from the ones managing the low-level systems, basically.
Correct. I think back in the day,
hardware.
it might have been more common, by the way. I think maybe way back in the day, it might have been more common than now, because most people now would just point to Red Hat or Divi and be like, they gave it to me.
Yeah, no, but I find it interesting that those people that supposedly are more aware of supply chain attacks, or maybe I'm also biased, but those application security teams that are very well aware by now of malicious open source components and the risks coming with the consumption, they are not in control, and they cannot do much about the lower operating system level through which some malicious stuff can also come in. And I'm not sure whether the IT teams are, on the same page in regards to the consumption of third-party stuff. So that's why I find it an interesting point here.
You're absolutely 110% correct, Henry. You'd be surprised how many developers have complained in certain communities I'm a part of. And they're like big name developers, and they're like, what do you mean I gave it to you? Like, you downloaded it, you installed it. But yes, you're hitting it right on the head.
Okay, so let me just write a quick note for this. Application development, secure development team. I don't have a better name right now. This reminds me, I mean, those let's say IT departments that manage the hardware and try to harmonize operating systems across the board, they also have a tough job, because you have kind of the individual developers pushing for all kind of operating systems. And so there's some developers insisting on Linux and others on Apple and God knows what. And at the end, those that insist on, for example, running Linux as a development platform, which is not well integrated with all the other systems of a bigger corporations, like the central identity providers also, they end up being in much less controlled developer machines and environments than the ones that go for the standard, let's say, Windows image that is managed from the central IT team.
Totally agree. Although I've been told that Apple is just Linux. So, as in, Apple uses Linux for all of their backend services. So,
yeah, no, I just have to think of a couple of former colleagues that spent hours and hours and hours in managing the Linux system inside a bigger development organization, and they couldn't connect to any of the other systems. They couldn't authenticate. It was just awful.
Wasn't it the government of Germany tried going all open source, and the experiment lasted like a week before they were like, nope.
I don't know. There were different experiments in Germany. I remember one from the city of Munich. I think many years back, they went away from Windows in order to deploy Linux systems all across the city systems. But after, I think, a number of years, they went eventually back to Windows. But it took them a couple of years.
I remember.
No, I think what is
like in the late 2000s. I remember that everyone was like, "Wow, like everyone's gonna use Linux at large," and then a week later, they were like, "Nope, not gonna happen."
No, I think it's in particular these hybrid environments that result in so much more management effort and that make control so much more difficult, that you have this, basically things going in every possible direction.
But let me also say this, that as someone that has actively works on trying to make Linux desktop a reality. Linux desktop is a weird animal.
Yeah, I haven't tried this for years and years, so I'm not sure where this animal is right now.
Well, it's a lot better than where it used to be, but it's still, it can be very strange. Like, there's a reason that Apple, like, even at Linux Foundation, most people will work on a Mac.
Yeah, there's this flame wars going on all the time about people from the OSSF and Linux Foundation working with Mac all the time, right?
Yeah, I think I'm in a like a group of one that uses Gentoo.
Yeah, no, I'm sorry to tell you, I don't know anybody else using it. So from my perspective, you're in a group of one indeed.
Yeah.
Good.
And then
Let
we
me-
have meetings. We have meetings at Gentoo. That is like 90% of users that try to install Gentoo can't install Gentoo, and we're like, yes, that's the way we like it.
All right. So I wonder whether we can actually turn this into maybe make this so rather. This was very particular for malicious third-party firmware and hardware. I wonder whether it's worthwhile transforming those thoughts we had into another thread or a general thread, such as this split between organizations caring for different parts of a stack, one for the development, one for the operating system, and that this is resulting in less oversight, let's say.
Yeah, I think it'd be good because it will be a whole list of security mitigations in addition to supply chain proper threat model.
Mm-mm-mm. Let's say development stack. Hmm. I'm not sure. I hope it captures it somehow. All right. Let me also link this one before. I'm not sure whether I can get the link out in a later spot at a later time. So this was Common Security Threads Open Compute project.
Henrik, for next time, I'm gonna see if a colleague of mine, Bean, is available to come to this call. He does a lot. He knows a lot of people in the kernel, knows Linus and everyone. But he does all of the training for security kernel wise. And for LF, like that's his main job is to maintain that stuff. So it'd just be interesting to get his insight in a lot of this because he has very, shall we say, interesting insights that come from way back in the day sometimes.
That sounds interesting. I would also love to have his feedback maybe on this research that was done by some US university a couple of, I think 1 or 2 years back, where they tried to basically suggest malicious pull requests and checked whether they were caught by the reviewers. There was a large debate about this going on. I'm not sure whether you're aware of that.
I think I may have read something because it sounds familiar, but if you have any links to share, I would gladly review them.
Yeah. All right. I think we, again, I mean, time flies. We reached the top of the hour already. Anything else that you want to have mentioned today before we close the meeting?
I'm good. Good call, everyone.
I think it's good.
Totally agree. And I think it's still worthwhile to discuss a little bit around the developer machine. So maybe we can even spend another session on that one alone before we move on to the other systems.
I think Bian will have a lot of good feedback for you here. So I'm going to invite him to our next call because he, as I said, he has a lot, and he's part of the Debian packaging team.
Cool. Great.
Maybe
Yeah, no,
maybe even reach out to the teams who usually manage developer machine to see what kind of thread they can think of. For example, Microsoft Desktop, Windows, or Linux Desktop, or whichever VMware Desktop.
Well, I think
manage
Linux Desktop and Mac OS, and I think we got a handle on that between me and Bian. Microsoft, though, I rarely use, only for video games.
Yeah, no, but I think what Victor meant is that we have. So I guess technically you can handle this. I don't have any doubt about this. But more from an organizational point of view, when you happen to work in an organization that manages those operating systems for the development workforce, that what are the typical challenges and problems that they face? I think that is maybe what Victor
because
meant.
they are the people who deal with this threat firsthand. Right?
Crow might have the resources to get us some people in that side of things. If you want, Henrik, I can ask him, or you could ask him. You know, Crow's pretty approachable. He's on PTO, but when he comes back, he knows, he has, I think, a fair amount of contacts in this space.
Okay, I will write him a message on Slack to see whether he knows anybody working for such IT system departments or so.
And then I think Andrew, obviously, and Jonathan Meadows from End User, they both maybe have groups or want to act as part of those groups, because I think both of them could fit that role.
All right. I think I'm not sure, one thing that I find is not sufficiently reflected is about what, I mean, here we speak of operating system, productivity software, IDEs, plugins, and so forth. And so here in the diagram on the right-hand side, we very well say this is kind of across the whole software stack. But if we look on the left-hand side, we stay very generic and high level without, it would be nice to have examples of all the different cases in order to give it some meat. One thing that I thought of a little bit earlier is that here, this one, use of non-improved distribution channels. This reminds me much of this Xcode Ghost attack from 2016 or so, where some kind of a malicious, I think this was this Xcode Apple development environment that was deployed and available for download on some Chinese mirror. And it exploited the fact that all the Chinese macOS developers or iOS developers wanted to basically downloaded it much quicker than from the authoritative sources. And so there was a vector to distribute a malicious Xcode environment. And I think this is something that we should do as where possible to have examples. And here is one. Okay, guys, unless there's anything else, I would close the session, and thank you again for this very nice discussion. I'm looking forward to speaking to you soon.
Thanks.
Bye-bye, guys.
Thanks, everyone. Bye.
Bye.